Undoubtedly, you have learned about matrices and their operation during your schooling, which may have prompted you to question where these concepts are utilized and what their significance is. In this video, you will gain an understanding of where matrices are used and what the significance they hold in various fields. The video covers the representation of textual data, networking graph, system of linear equation, and digital images in matrix form. Matrix theory and matrix algebra is extremely important in the field of linear algebra. During your schooling, you must have learned about matrices like its array of numbers, symbols, or expression in rows and columns. Or it's a mathematical object that represent collection of data or information in structured way using rows and columns. Or simply you can say that it's a grid of numbers or other mathematical entities. Here we are going to convert this textual data into matrix form. The price of pen and notebook is different in these cities. A pen costs $3 and of notebook costs $2 in London city, while the price of pen is 5 and of notebook is $4 in Melbourne city. Similarly, the price of pen is 8 and of notebook is $6 in Dubai. This data can be encoded in matrix form. Let's see if this makes sense. Let's create 3 columns for 3 cities and 2 rows for pen and notebook. I will write L for short to represent London city, M for Melbourne, and D for Dubai, P for pen row, and NB for notebook row. We have the price of pen in London city is $3. So we have the price of pen in London is $3. This corresponding entries of London column and pen row. Then we have the price of notebook is $2. That's this right over here. And this first column looks like London city column, while this second column looks like Melbourne city column, where the price of pen is 5 and of notebook is $4. Similarly, in the Y column, the price of pen is 8 and of notebook is $6. And here we get the matrix with entry 3, 5, and 8 in first row and 2, 4, 6 in second row. That's how we set up the data right over here. That's what's interesting about the matrices. The matrix that we have is useful because a computer could make use of this data as long as it knows what these rows and these columns actually represent. So here the question, whether the following matrix can also be used to contain the same information. So data is this. The matrix with entry 3, 5, and 8 in first row and 2, 6, 4 in second row. This matrix doesn't represent the same information because this 6 represent the price of notebook in Melbourne city, but in reality the price is $4 in Melbourne city. If we switch these two values around, we will get the same matrix as this. So you can't just randomly order these values around, but you could represent it another way. Let's say I have the matrix. We could have picked to do something like this may be the pen column and this may be the notebook column, and maybe this is the first row to represent London city and second for Melbourne and third for Dubai. You could have done something like this. Pen in London city was $3 and notebook in London city is $2. Pen in Melbourne is 5 and of notebook is $4. Similarly, pen is 8 and of notebook is $6 in Dubai. So this metric right over here representing the same information as was first matrix, with entry 3, 2 in first row and 5, 4 in second row, 8, 6 in third row. This matrix also representing this data. Here we will represent relationship network by matrix. This purple arrow right over here is for friendship relation, blue for colleagues, and green for fellows. Let's create 4 columns and 4 rows for 4 names of people. John for short, J, S for Smith, F for Finch, and R for Ricky. So similarly, J in first row, S in second row, F in third row, and R in fourth row. Let's look at network. John is connected by himself with this self arrow. So I will put one right over here. John is connected by himself only one way. Let's move forward. John is connected with Smith by this arrow, and that represents they are just colleagues. So this is going to be one right over here. So we get one there as well. John is connected with Finch by three arrows: green, purple, and blue. They are friend, colleagues, and fellows, so we get 3. Similarly, you can fill this out. I encourage you, if you feel so inspired, pause the video and see if you can fill out this matrix right over here. And here is the complete 4 by 4 matrix. So this network and matrix representing the number of relation between these 4 peoples. Here we are going to represent triangle by matrix or matrix by triangle. Take a look at the triangle, and points making up this triangle are set up in matrix. That matrix where the first row is all the x coordinates and the second row correspond to all the y coordinates. We have the point at origin means 0 0 point, 1 2 point, and third order pair is 3 0. So just combining these points we got this triangle. Surely we can transform this by applying different operations on matrix. Let's say just multiplying this matrix A with 2, we got this matrix, and the image is going to be like that. This is the transformation. Further in detail you are going to see in future videos. System of linear equation. You can solve this system by various methods. By using matrices make life easier, because we can use a computer program to solve this system or some huge system. But first we need to write this system in matrix form. We can write the above system as column picture, like x times 3 in first equation minus 6 in second equation and 2 in third equation, plus how many y's in first, second, and third equation. So how many y's in first equation? 4, in second equation minus 2, and in third equation 1, plus z times minus 1, 7, and 13. So I have to combine this column to produce another column right over here, and which is consist of the number 29, 16, and 9 in rows. So here's the representation of system of linear equation in matrix form or in column picture. This system can also be represented the matrix form using coefficient of matrix, variable matrix, and constant matrix. The coefficient matrix can be formed by aligning the coefficient of the variable of each equation in row, like 3, 4, minus 1. So the first coefficient matrix will be the matrix consisting of the elements 3, 4, minus 1, minus 6, minus 2, 7, 2, 1, and 13. This is the coefficient matrix. The variable we have are x, y, and z. So we can write the variable matrix as x, y, and z. On the right side of the equality, we have constant terms of the equation. The 3 terms corresponding to first, second, and third equation take the place at the first, second, and third row in constant matrix. So the matrix becomes like that. The above system can be represented as in metric equation. Digital images. How are images saved as matrices on computer? Let's take an example of grayscale image. This is the image of number 8. If we zoom in further and if you look closely, you will see that images are getting distorted, and you would see some small square boxes in image. These little boxes are called pixels. Image's dimension is simply the number of pixels across the height and width of the image. In this case, if you do math, would be 24 pixels in height and 16 pixels in width. So therefore the dimension of this image will be 24 times 16. So each of these pixels is a label values as numerical values, and these numbers are called pixel values. These pixel values indicate the pixel intensity, like this pixel is completely dark, so its pixel value would be 0. For grayscale image, we have the pixel value ranging from 0 to 255. Smaller number closer to 0 represent the darkest shade, while the larger number closer to 255 represent lighter or white shade. So every image in a computer stored in this form, where you have the matrix of number, and this matrix is also known as channel. Similarly, a color image is made up of many colors, and almost all color can be generated from these three primary colors: red, green, and blue. We can say that every color image composed of these three colors.